You ready? Well, hey y'all. I really appreciate the chance to be here today, and I wanna tell Jessica especially thank you because she got on the process of organizing this meeting clear back in July. I mean, to me that indicates a high degree of passion for the subject matter. So y'all are lucky here in Clay County to have somebody like her with the passion to move forward on a project like this. Um, I am a little bit of an apostate animal science grassland scientist. Um, I didn't grow up in the Flint Hills. I chose the Flint Hills, or maybe the Flint Hills chose me is a more accurate way to put it. I'm originally from northwestern North Dakota, where the growing season is about 4.5 months long, and the grass in a high moisture year, which would be about 12 inches, gets about 3 inches tall. Uh, I first saw the Flint Hills in 1990 around Christmas time, and it blew my hair back. I had a lot more hair then. You know, the grass was stirrup high, and I was coming through the state on the turnpike really early in the morning, and I could see, the grassland alone really caught my eye, but I could see ranch brands painted on semi-turnouts that were up and down the turnpike, and I thought, wow, what a great place to be a livestock producer. What a great place to be a land manager. And it just so happened that 2.5 years later, I had the chance to come to the area and work and learn about this place, learn about how incredible it is. Uh, that Rorschach blot is the original extent of tallgrass prairie in North America. And you can see that there's even a little bit of tallgrass prairie close to where I grew up, which is about right here. Okay, but it was all over the place. There was over 165 million acres of tallgrass prairie. That happened to be where there was good soil in most locations. And when European settlers came to this area, it was converted to tillage. We got corn and soybeans and things like that. And so it's not tallgrass prairie anymore. Places where you go where tallgrass prairie is an anomaly, they build a fence around it and they make it into a monument. It's really special. But we live, sorry, the buttons are new to me on this controller here. We live in the last remaining and really manageable example of tallgrass prairie. There's just a tiny fraction left, okay, that I would call of a scale large enough to manage and large enough to preserve. And we're lucky enough to be right here in it. I want to do a little salesmanship this morning if I can. Have y'all ever heard the term ecosystem services? It's kind of like a tree hugger thing you hear about in the news once in a while. I don't think of myself as a tree hugger, but I think silently I'm becoming one against my will. The Flint Hills are a provider of ecosystem services that most of us don't even think about. And certainly, our neighbors in Kansas City and Wichita don't really think about. On small spatial scales, there are more species that call this place home than anywhere else on planet Earth, including the Amazon River Basin. Okay, there's 500 plants, there's 700 insects, and there's a whole host of two-legged critters and winged critters that aren't even on that list that call this place home, that only live here. Okay, what would planet Earth be like if those things ceased to exist? I don't know, but it can't be good. Okay, and every person I know likes to draw a breath of clean air. This grassland, because of the depth of the sod is one of the best carbon sinks, maybe the best carbon sink, carbon scrubbing system on planet Earth. Okay, and everybody likes to drink clean water. Okay, and prairie sod is one of the best water filters on planet Earth. Okay, we get all these things because we have this intact grassland, and anything that interferes with or compromises that intact nature reduces water filtration, reduces carbon sequestration, and compromises, the web of life that we have here in tallgrass prairie. Here we go. So fire has always been a part of this ecosystem. Okay, as long as there has been tallgrass prairie, fire has been a naturally occurring phenomenon and a prescribed phenomenon. Y'all know who Frederick Remington is, right? The cowboy artist, probably only slightly less well known than Charles M. Russell. He painted this from memory at least 40 years after he saw it. And there's a lot going on in this picture. Okay, where are the humans? Are they upwind or downwind of the smoke? See, the wind is coming like this. The little smoke trails are blowing like this. They don't have smoke in their eyes. They know what they're doing, right? It's obviously dark. Okay, not that we would recommend burning in the darkness in the 21st century. They did it because they knew the wind would be calmer and more manageable. They were burning for a purpose. Okay, we don't know what that purpose was in the photograph, but prior to European existence, fire was used for a multitude of purposes. Okay, the thing that you learn in grammar school is that Native Americans used fire to attract bison. Everybody knows that. So we can, shoot some bison and make clothes and eat meat. But it's been documented, okay, that some of these Aboriginal tribes used fire to condition stone and wood for tool making. They used fire to cause proliferation of certain food plants, okay, that they could go out and harvest. They knew a lot of stuff. Okay, and a good thing is that when our ancestors got to this country and started bringing their cattle and putting down their roots, they got some of that wisdom from the Aboriginal peoples of the plains. Okay, they noticed, because it was very obvious, that large grazing animals are attracted to areas that have been burned. So that's what they copied. They recognized that when cattle were grazed on areas that had recently been burned, their performance was better. Okay, and we kind of stuck with that, and we kind of forgot about all the rest of it. But that adaptation, okay, to a fire culture, okay, is the main reason why we still have 150 years since that lifestyle has disappeared. It's the main reason that we still have this intact grassland that we call the tallgrass prairie. So everybody knows that fire can and should only happen in April of the year, right? If you ask a lot of people, that is the response that you'll get. But early on, when Europeans started to come to this country, most of them were at least amateur naturalists, if not having some formal training. And on their journeys through the plains, which usually had some commercial purpose to it, okay, their side job, if you want to call it that, was writing down what they saw. That's what naturalists did. Call them range scientists if you want to, but that's what the first range scientists did. They wrote down what they saw. And these folks, going back clear into the 1500s, okay, recorded that prairie fires happened every month of the year by witness in writing, except January. Okay, and they also differentiated between natural sources of ignition like lightning and prescribed sources of ignition. Okay, and their observations tell us retrospectively that Prescribed fires were common in the spring and in the fall, and natural ignition fires were common in the summer. Okay, it just was what it was. The other thing that's interesting about this record, and this comes from something called dendrochronology, it's a hard word. Okay, but looking at old growth trees, and once they've been cut, looking for fire scars in and amongst those rings can tell you how often fire passed through a landscape. Okay, and a study that was partially done at the Tallgrass Prairie down in Strong City indicated that for the last 300 years on average, okay, fire came through every 2 years. It's just a skosh over 2 years. Early on in that 300-year period, okay, there was a longer interval of time between fires. It was maybe 3 or 4 years. Since European settlement, that frequency has picked up, okay, to less than a 2-year fire return interval. We just got a wonderful object lesson today for one of the reasons why it has needed to pick up. Okay, prior to any of our ancestors being here, there were no trees. Okay, that's another thing you pick up from those pioneer journals. Some people went, that were from the East or from Europe, where savanna landscapes that had big mature trees were the normal thing. They got out here and couldn't find a tree, and they went insane. Okay, they couldn't take the broad, wide open landscape that was treeless, and that kind of mindset, has led to fire suppression. Whether we think about it or not, we inherit fear of fire, okay, from our European ancestors. Now, I cannot dispute that the main enemy for the continued existence of tallgrass prairie and other prairie ecosystems is woody encroachment. I don't dispute that at all. But there are things that we are doing to ourselves politically, okay, and economically that are really difficult to control. Okay, when land values get beyond a point where you can cash flow them with agriculture, particularly livestock agriculture, land fragments. It gets put into smaller and smaller pieces. That means more and more different management styles or lack thereof. Okay, and the likelihood of landscape scale fires coming through to kind of clean things up, to get rid of those woody species gets less and less. Okay, and we have this tragedy, I've heard it called the Green Glacier, marching westward across the plains. And I lament this. Okay, I know it's the biggest problem. It's just not my focus. I want to talk to you about what some people call herbaceous invaders. Okay, invasive plants that come from someplace else that have been introduced to this area but do not have a woody stem, and in their way are every bit as destructive as the eastern red cedar. This class of plants is called transformers by big-headed dudes that do ecology for a living. And by big-headed, I mean big brain, not egotistical. But these transformers can get into an otherwise healthy ecosystem and change it completely. Okay, they do it a variety of ways. They can toxify the soil for their own purposes. They can decrease native diversity to the point where it's just them and a few hardy native neighbors. But they're unusual plants. The two classes of plants, one species, one class of plants that we have here in Kansas that are transformers are the class of plants known as the old world blue stems, okay, and the plant, the herbaceous forb, Sericea lespedeza. Both of these were brought to our area for their perceived value for forage, they wound up making a huge mess. In some cases they were relied upon to reduce soil erosion or to repopulate soils that had some heavy metal issues. The result was the same. They didn't stay in the location that they were intended to stay. This is an example of an old world blue stem. This is Caucasian blue stem. Produces a lot of forage. Its name is blue stem. It kind of sounds like it belongs here, but this is a far Eastern European, far Western Asian genus. Okay, it does not belong here. It sort of looks like little blue stem, grows a lot of biomass, but it matures very quickly and rapidly becomes a thing to be avoided by domestic livestock. Okay, it has a narrow window of high quality grazing and followed by a long window of don't want to eat it because it tastes like lumber. There's this one. There's also yellow blue stem that's very similar. Now, Sericea lespedeza has been on our radar for a little bit longer. This map was published in 2023, indicating areas of the country where Sericea could grow and where it was growing, and where it was growing and what relative abundance it was growing. This red circle right here is the approximate location of the Flint Hills, and basically going from where there is potential, environmental potential for it to grow, to where it is relatively highly abundant. You see the Flint Hills, that little finger shape of the Flint Hills showing up in every one of these maps. Now, every couple of years, the Kansas Department of Agriculture puts together a Sericea lespedeza distribution map statewide, and it's never been very complete to my satisfaction. In the counties where you see a pink to red color, that's where Sericea is present or has been detected. These counties that have kind of the black cross hatching have no data. And the deeper the red color gets, the more serious the infestation is. The frustrating part for me is that some of the counties we know are focal locations for Sericea presence, like Wabaunsee, that's close to my county, don't report any data. And it always seems to be that Greenwood County here, that's Eureka, is sort of like a focal point of invasion for Sericea lespedeza for the state. Whoops. There we go. That's the right direction. So Sericea comes in. It pushes, and old world blue stems come in, and they push native species out. They do that by just occupying space. Okay, they do that by filtering sunlight before it can get down to native plants. That's canopy dominance. They do it by changing the nature of the soil, okay, that favors their own growth and inhibiting the growth of other plants. And so we get this decline in diversity, and some of that is plant related. Okay, we lose some of these sensitive legumes like cat claw sensitive briar, white prairie clover, among others, that are there enriching our soil, okay, with nitrogen under normal circumstances. And when they're gone, we lose our natural source of fertilizer. Okay, and when those plants that also happen to be nectar bearing leave, okay, the little critters like the blue swallowtail and the dickcissel, okay, we're looking at a food chain here. These butterflies eat nectar from these plants. These birds eat this butterfly. Okay, when plant diversity goes down, diversity on every other level follows. We wind up with a three-legged stool where one leg is shorter than the other. It's one of the reasons to be very careful about using herbicide to control noxious weeds. Okay, herbicides don't care if they land on a good plant or a bad plant, they're going to kill. Okay, they're specific to classes of vegetation, rarely species of vegetation. So, diversity, if you're a tree hugger, I guess I'm one of those now. Diversity loss, okay, is a real cost of invasion. Okay, but there are other economic costs. And if we use Greenwood County as an example, that distribution map that I just showed you from 2022, okay, Greenwood County has about 1,150 square miles in it, and an infestation, okay, at 11 to 14% of that total acreage, that's been at least 80,000 acres. Okay, and assuming that 80,000 acres has been degraded to the point where its carrying capacity has diminished, these are the numbers that fit into that space. Okay, that would leave room for about 27,000 more 30-day or 90-day yearlings. Okay, about 5,800 more cows, okay, that are not there because Sericea lespedeza is there. Okay, and people say, why can't they just eat it? Why can't they just eat that Sericea lespedeza? They're herbivores, right? Well, it's mildly toxic. You don't want your cattle to eat Sericea lespedeza. And we can talk about why biologically that's true if we have time. So, I've been thinking about this problem, been thinking about the Sericea lespedeza problem for very close to 20 years. Okay, and doing research in it as a K-State employee for that period of time. I'm in the process of separating from K-State so I could do something else. Okay, but this is something that kind of capped off my career at KSU. Starting in 2014 and going back a few years before that, I started to think, okay, about the growth cycle of Sericea lespedeza, when it flowers, when it produces seed, and if there was some logical control point in that life cycle where if we applied a control measure, we could apply some extra hurt to the plant. Okay, and real basic plant physiology says that plants become vulnerable. They mobilize root carbohydrate reserves to produce flowers and to produce seed. That makes sense, right? Okay, learned that in high school VOAG, I think. So I thought, well, we got this fire culture here in the Flint Hills, and we probably have more flexibility than we think about when and how we use prescribed fire. What if we look at how fire season influences Sericea lespedeza? So, and David was the main guy that got this research project off the ground. David, that was up front here a few minutes ago. So we found a ranch in Geary County that had a significant Sericea lespedeza problem. We chopped off some small portions of it and made some replications, and we applied fire over a period of 4 years in either April, August, or September. And we just watched what happened with the Sericea being the main target. Looking at the number of the seed, okay, is the way that Sericea spreads geographically, moves from location to location. You've seen Sericea seed before, I bet. It's small and hard and round. It's a lot like sorghum grain. Okay, very durable seed. One way that I thought we could control it by putting fire on it late in the year as it was flowering and setting seed is through seed production, diminishing it. So in the month of April, when we applied fire, came back in November and harvested the seed off those plants, individual stems were making over 700 seeds per stem. You know, and there's like 30 stems per crown on a plant. When we put fire on it in early August, that number was less than 50. It was about 30, 33, I think, seeds per plant. And this number here is not 0, but it's less than 1. And statistically, these numbers are the same. They're not really different. But we started to think, okay, maybe we're on to something here, because this is something that over the 4-year course of the study happened right away. Okay, it happened every year. We got this great reduction in the amount of seed that was produced. What we didn't really anticipate is that with repeated application of fire, the mature individuals that were part of those pasture systems were also being harmed, okay, by that repeated application of fire. The dotted line there is Sericea lespedeza basal cover. That's how much total ground is being covered by the basal area of Sericea plants relative to all the other plants and litter, dead plant material. So the dashed line there is where we started. Okay, when we burned exclusively in April for that period of time, we got more basal area. It went from about 4.5% to about 7.5% over that period of time. We got a little bit of a reduction. We moved fire season to August. We got a significant reduction, okay, more than 50% in that Sericea lespedeza basal cover when we moved fire season to late August to early September. There we go. The other thing that sort of followed, okay, the diminishing of seed production and the diminishing of basal plant cover was simply the size of the plant, the physical size of those plants that remained. Okay, when we took individual stems after a killing frost, dried them out, weighed them, okay, the surviving individuals following that early September fire regime, okay, were tiny. Okay, there wasn't, sorry, not doing what I want here. Okay, they were tiny. Okay, well under a gram per plant, whereas those plants that were not affected by a growing season fire were 4-fold to 40-fold heavier and more robust. So we're hitting the plant in 3 ways. Okay, we're making less seed. We're getting fewer plants over time, and the surviving individuals are getting smaller. At the end of this process, we had to hunt to find Sericea plants. And in going through the process, years vary, right? We have dry years, we have wet years. We've had two years that have just been fantastic for Sericea growth. It seems like after one treatment, you just make it mad. Okay, but if you hit it enough times, pretty soon its teeth start to fall out. So last thing on Sericea here. At the very last year of that study, we went out and clipped some plots and separated the forage into Sericea biomass and non-Sericea biomass. And one of the things that was really pretty neat is that in that August fire regime, which is, I don't know what I just did. There we go. In that August fire regime, we actually had the most non-Sericea forage biomass compared to the other 2 regimes. I mean, at a very basic level, this tells me, and anybody that's honest about consuming it, is that there's nothing unnatural about prescribed fires during the summer of the year. Nothing unnatural at all. The ecosystem just smiles and asks for more. Okay, and quite possibly, there are things that are happening that are positive but very subtle. Now, one of the questions to ask when you do something radically different than what's normal, okay, we're going to naturally focus our attention on targeted species, but what's going to happen to everything else? Okay, in this circumstance, the answer was not much. Okay, one of the things that was alarming, okay, is that total perennial forb cover dropped, okay, by a pretty substantial margin on those summer fire regimes. But we could explain that drop in basal cover in just 3 species: Sericea lespedeza, Baldwin's ironweed, and western ragweed. Okay, we struggled to control or to live with all 3 of those plants. Okay, moving on to a different highlight from the same table. Okay, a group of 8 to 12 plants that I call major wildflowers. I'm sure they have a better name in somebody else's dictionary. Okay, plants that are leguminous, plants that are nectar bearing. Okay, when you lump the population of all those plants together, okay, they jumped by about 50% for the August fire regime. They about doubled for the September fire regime. Okay, these are those functional plants that make the ecosystem complete, that feed the bugs, that feed that feed the butterflies, or the birds rather. Okay, without them, we have the 3-legged stool that has 1 leg too short. Our country, okay, likes that kind of fire, responds very positively to it. I should say that the burn history on this site was exclusively spring, and it was very nearly annual prior to the time that this study was initiated. Diversity improved. I can skip this part, I bet. You know, the question we kept getting asked is, okay, we can control Sericea lespedeza. I understand that if I only use chemical, I'm going to be sacrificing some of the forb component on my rangeland, but I'm not going to give up the extra 25 or 30 pounds of stocker calf performance that I get every year with a spring burn. Boy, you're quick. And so, you know, due to the benevolence of the former Dean of Ag at K-State, we got some money to take a long view of that question. If we move our fire season to either summer or fall, compare that with spring, what's that going to do to performance of yearling cattle? And the answer to that over a 7-year time span was not much. Okay, using summer fire as the zero, okay, these would have been fires that were conducted in the month of August. You know, the cattle that grazed April burn land gained about 10 pounds more. The cattle that grazed October burn land gained about 5 pounds less.
Is that the following year? The 4.5 less of the following year? The current year?
Yeah, no, that would be the following year. So all treatments got applied before we ever weighed a steer. So there was some sacrifice in performance that is real, but it was small. And you know, if you're a cow person, this performance difference matters not at all. In thinking about, you know, I can show people this data all day long, and I can tell them that 10-pound difference in weight is very easy to overlook, and just in how animals shrink while they're waiting to get on a truck. Okay, 10 pounds can get overwhelmed in an hour of standing around waiting to get on a truck because animals continue to urinate and defecate. It's very small and not likely to be economically significant very, very many years. I can show them this all day long, and they say, no, I can't do it. I need fall grass, or I need winter grass. I can't burn it up in the late summer or the early fall. If you want to bad enough, you can. I got interested and passionate about herbaceous invaders because I'm a Flint Hills landowner. Okay, and I deal with this problem just like everybody else. And about 2016, these results started to come in. I changed my management because I was sick to death. Okay, riding around on a four-wheeler for 6 or 8 weeks a year looking for sericea plants, hoping I could find every one and putting a little squirt of escort on. So for 3 years, I burned my whole place in August or early September. And for 2 years after that period of time, I didn't find a sericea plant. And so my response was, great, I can go back to doing what I've always done. Stupid. I just got done living the worst sericea year I've ever had. After several years of spring burning only. I'm gonna go out on a limb here. If we're gonna keep this plant in check, if we're gonna lock the doors on it permanently, we are talking about a permanent change in management. We're not talking about flipping and flopping back and forth. I'm not saying exclusive summertime burning. I'm saying regular summertime burning is what's going to keep this thing in check. One of the reasons I'm having such a bad year this year, okay, is because I can't see all the plants all the time. Okay, my place isn't that big, and I'm on it, out in it every single day. Okay, and I found about a quarter-acre patch of sericea a month ago, after too late to do anything about it other than clip it and hope I didn't knock any live seed out on the ground. And I was just kicking myself because I knew better. We can't go back to the status quo and hope to retain what we have won so far. We just can't. So this guy is one of my friends. His name is Warren McCoskey, and he works for Wichita Parks and Rec, and that's okay. So Warren got really interested in what we were doing, and he sent me some pictures. So this is one of their properties that I think sits, it's in Sedgwick County, but it's well east of Wichita. This tree back here, okay, I kind of picked out as my landmark on these pictures. So this is pre-treatment. This is post-treatment. There's that same tree. And this is a quote from an email that Warren sent. Thought you'd be interested in what a difference 4 to 5 August-September fires makes in the sericea. And the rest of it is added by me. Now, you'll hear people say that this technique does not work. I would say the evidence is very strongly against that. And I would say that that statement runs counter to just basic understanding of plant physiology. It works. You can bank on it. And me sitting on some kind of a machine, squinting, trying to find sericea plants that are tiny, okay, to put spray on, just doesn't work. I'm not going to find, maybe even 10% of them. Okay, but fire doesn't miss a trick. Fire sweeps through an area. Wherever that fire passes, every plant is affected. Every single plant. I don't have to see them all. Yes, sir.
Does that do much for controlling the seeds that's already in the ground?
Yes. So this is something new. We didn't cover this in our study, but we speculated that one of the mechanisms for control is that lots of seeds require scarification for germination. The seed coat has to break apart just a little bit. Fire is a great scarifier. So in the case of sericea, when that seed is cast in the fall and fire passes over it, okay, that seed coat cracks, the plant germinates, but it's like it's waking up at the wrong time. Okay, it germinates in the fall, It uses all of the carbohydrate reserve in the seed just to get, a little bit of above ground biomass. Doesn't have anything left. Okay, it winter kills. Okay, and Oklahoma State just recently verified that with some greenhouse work.
So how do you get it to burn in September when it's green?
What takes the fire and carries the fire is the dead plant material on the soil surface. It's one of the reasons that makes the fire different and I would say easier to manage. Flame height is not as big, heat intensity is not as great. If you want to look at some videos later, I can show you a video of one of my students standing in a head fire with a camera watching it burn and show you a comparison picture of what a spring head fire is like. Want to see that?
I know what it's like.
Kind of cool.
I've been there. But so you're saying that just the dead stuff from prior years on CRP will make it burn good enough to get
On CRP, on native, yes. That's what's going to carry the fire. So one of the things that we noticed when we were doing kind of round 2 of this research is that patches of yellow blue stem on that second research site that we put fire on were difficult to find the next year. So this also happens to be a plant that matures about the same time that Sericea lespedeza does. Yellow blue stem in that case, Caucasian blue stem in the case we're about to consider. So let me see if this video will play, and you can tell me if you can detect a difference. Oh, it is playing. Good deal. Any difference that you can pick up from right to left? Okay, this place is in Ellsworth County. It's got a patchy infestation of Caucasian blue stem. And we decided to try this technique. Compare no fire. I mean, that's not fire culture country out there. We compared no fire with fire applied one time, 1 year, versus fire applied twice, 2 years apart. And just looked at what happened to the plant community. This is what we got. So basal cover of Caucasian blue stem before treatment was about 32%. Okay, in the control area that was not treated with fire, that jumped all the way to 50%. Okay, year 4 after treatments were initiated, we dropped it down to a little under 20%. Okay, where the fire was applied twice. When we found, because this is a bunch grass like little blue stem, when we found bunches of Caucasian blue stem in the winter season, they all looked like this. There was a little ring of whiskers around the outside, and there was a dead core. If we found one of these things that was horseshoed, okay, where one of these borders was actually reamed out, those crowns never came back. If you can break inside that ring with your fire, it just about lazed your eyeball. Those crowns just died. Same data set, but this time we're looking at, frequency in a 30 square centimeter area. This was on this site, Caucasian blue stem was the dominant plant. Okay, but we were diminishing its physical presence the same way we did with Sericea lespedeza with these growing season fires by applying in August. So I just want to do a little practical pitch to close things up here. using fire as your primary means of herbaceous weed control will save you time. I have a smartphone, but my brain is the IRM Red Book. Okay, everything I do is written down in it. My daily activities are jotted down in it. Looking back through Red Books over a period of years, days or partial days I spent burning from 2018 to 2023 were 38. Days I spent spraying, more than twice that many. I can save money. Okay, the cheapest herbicide that I can use costs about 17 bucks per acre. Okay, how a farmer, a rancher would apply it. Something that's a little higher end, okay, costs about 61 and a half bucks an acre. Over the course of our animal performance study, okay, doing this for 6 years, our average performance loss, if you want to call it that, was just under 10 pounds in a 90-day stock or steer season. And just note that there were almost 2,000 cattle involved in that comparison. So, take you through a bunch of boring math here, but putting the value of that performance sacrifice on a per acre basis and comparing that with the herbicide cost on a per acre basis. Okay, I am 12 to 56 acres to the good. Okay, accounting for that performance reduction by substituting burning for herbicide application to control herbaceous invaders. Okay, there's no real argument that can be made against it from a cost standpoint. That does not account, or that doesn't pay for my time either. That's just treatment cost. So just to finish things up, you know, I showed you the highlights of the data. Okay, we got improvements in diversity. We got diminished presence of the nasty invaders that we were trying to target. My colleague Lydia Zeglin in biology tracked soil organic matter changes, okay, over the course of the second of these studies. And surprisingly, okay, soil organic matter increased faster in the summer burning regime than it did anywhere else. Pretty amazing. This is an important point. The assumption, because we burn in the spring usually every year, that's the normal thing, we have to burn in the summer every year if we want to get this kind of an effect. Good news is you don't. Okay, we burned every year because we assumed we had to. We assumed that we had to fall in line with Flint Hills fire culture. And it was every other year it was hard. Every other year it was hard to develop a fuel load necessary to get a fire to carry in an easy way. You know, our ranchers went, I'm not doing that. It takes too much work. Okay, so they went to a system where they were applying fire at an every other year or an every third year kind of a manner to get ahead of their Sericea lespedeza. And they got the same result. It just took longer. You know, and if you're thinking about not being able to get by without fall and winter grass, okay, think about putting your summertime's prescribed fire on a rotation. You know, if we can get this kind of control with a 3-year fire return interval, still keep control of woodies, okay, with that kind of a fire return interval, just move that burn patch around. Okay, save 2/3 of your forage for fall and winter grass, put fire on the other third, okay, and then move that third to to a different location the next year. So it may take 3 years or it may take 10 years. But if you get 3 treatments on the ground and going back and look the next growing season, you will be able to visually appreciate the difference that you've created. I mean, we won't admit it, okay, but when we're in the business of helping people manage, helping people improve, it has to look right, okay, for them to want to do it. That's the standard that we're trying to hit. Okay, and 3 treatments on this technique will make it look right. It will make it look so different, okay, that with the naked eye, you can go, wow, that's better. I like that a lot more than what I had before. So this is from KDHE, and it only goes through 2023, but it shows, okay, the acceptance over time, going back to 2014, of growing season burns and how those have changed. This is just during September and October, doesn't include August. Okay, but it shows acreage in the Flint Hills trending upward over that period of time based on fire scars that can be detected by satellites. And I'm proud to say that we had our first air quality exceedance in August of 2024. This is Sedgwick County and looking east. So folks are listening. That's what I had put together for you this morning. And if you want to look at some cool videos, I've got those. Or if you want to talk, we can do that. Or if you want me to shut up so you can eat your lunch, I can do that as well. So,
have you put in the goat type of management into your burning deal, or have you, like in the spring, is that any difference?
So small ruminants we've evaluated separately as a control mechanism.
But not integrated with the burn?
No. And can I tell you why? There's a glacier-sized logistical issue there. So on a landscape scale, the number of small ruminants it would take to control an herbaceous invader like Sericea lespedeza, that number of goats doesn't even exist in Texas. You're talking 8 goats per acre. If you use sheep, you're talking about 2.5 mature ewes per acre. We have 120,000 small ruminants collectively in Kansas, according to the 2022 Ag Census. If we go to another state and say, y'all come and bring your small ruminants here, we'll custom graze them for a season, the timing doesn't work. Because when they run out of forage, it's a different time of the year than when we have to treat our problem.
So it would not help to have the reduction in the spring by the goats and then burning in the fall.
No, it might. I'm just saying that the size of the help, the degree of the help is likely to be small.
So like I understand the fall burn deal. I'm a cow guy. We graze all our grass, pretty much. We winter a lot of native grass.
Yes.
We run 12 acres of pears, so we can't have that springtime burn every year after winter. So my first question, I guess, is like in your fall burning on a dry year, it turns dry. Erosion. I mean, do you see that? My second question is, down where we're at, keeping fescue out of pastures is tough in places. So how much more fescue do you see encroaching in fall burns than native?
On the encroachment issue, 0. If you get your burn too much into the month of October, what comes in usually is bluegrass, and it doesn't last very long. Fescue doesn't seem to like the August to September fire window very well, and I can't physiologically explain why that's true. I had a lot of fescue on my place. Cows were my primary control mechanism, cows in winter grazing. Um, I lost that fescue component almost completely by 2018 after 3 consecutive summertime burns. And for me, my solution was I'm just going to move the cows off of the property I own for the winter. I don't do that anymore. Okay, my burn area just moves and the cows go eat someplace else. Second question about soils and erosion. So what I will say is just a categorical no. We don't see erosion or loss of soil cover with late summer, early fall burns. The plant crown is still there. That's what's holding the soil down, not the above ground material. We'll probably get less water holding capacity, but it hasn't been significant enough, with our limited snowfalls to really register in productivity on the following year. We get the same biomass regardless of when we burn. There was something else I was going to throw in there. Now maybe it'll come to me. I'm approaching 60, so things just fly right out of my head with annoying regularity now.
I think it's sometimes too are more intense rainfalls happen in the spring than they do so in the fall.
That's what I was going to say. Thank you, David.
So are you saying
Let me finish this before I lose it again. So when you're monitoring rainfall for drought management purposes, you do it from November 1 to August 31. You follow the water here. When you're making a decision to burn in the spring, you don't have very much of the water you're under your belt. When you're making a decision to apply or withhold fire in the summer, you've got about 90% of it under your belt. You know whether it's an acceptable fire risk year or not, much more so than making that decision in the spring. That's what I wanted to say.
In the springtime, you make a decision because the neighbor's gonna burn.
True.
I mean, it's like, can you keep it off,
And
So many, a lot of times.
I mean, the compromise that I've arrived at with my neighbors is, okay, I don't want fire on my place. I'm going to help you backburn around my place and around my structures. We don't have a PBA in North Lyon County, but we have sort of a functional PBA. Everybody gets together and does it. And thankfully, there are diverse goals, and we can accommodate people's goals. We always have to burn around cattle that are still out on grass. We always have to burn around people's structures. It's not that big a deal to say we're going to keep fire out of this piece this year, so we can do something, so we can work toward a different management goal for it. It's not an unreasonable request to make, I don't think.
and typically spring burn areas will not be very susceptible to being exposed or even carrying a fire in August or September because you don't have that dry mulch to carry through that green stuff.
Once I've got a patch around the buildings that I own, maybe it's just one direction from those buildings. But once that patch is cooked off in the summer, I don't have to backburn on that side in the spring when the neighbors burn out. It's kind of nice.
Seems like the problem with burning is still trying to convince people that they should do it. And instead of wondering, well, when is my neighbor going to do it, is to see if any neighbors will ever do it and see all kinds of problems with burns. You get your control burn ready to go. And that's not the kind of weather that you see a wildfire, which we're not looking for a wildfire. The wildfire goes when there's the lowest humidity and the best conditions for a fire. So the nature's fires that we talk about or that we see, we need that kind of burn. And a lot of people are just scared of it, or they don't have the money or the manpower, all these different things. There's so many different things. If we can just simply use it, it's good across the board, it seems
It's
like.
true. You know, in 1999, that was well after my first exposure to the Flint Hills. We had a bumper year in western North Dakota. We got 18 inches of rain, and going into the fall, we had more residual forage than anybody had ever seen. Predictably, the wind came up, power lines started knocking together over in Montana, started a wildfire that burned off. You know, it wasn't enormous, it was about 150,000 acres, burned us out, lock, stock, and barrel. You know, and looking back since then to the Starbuck fire, to the Anderson Creek fire, same kind of scenario. You know, a year where abundant rainfall resulted in a larger than average forage mass. Early spring conditions are predictable with volatile winds. Okay, all you need is an ignition source. Boom. Then you got a mess.
I'm cutting pastures where the years past, it could be 20 years ago, they've got piles bigger than a 3-story house that we were talking about here last break. And people are so scared to burn even their own burn piles. And now you're back cutting more trees around the burn piles. It's just ridiculous, the need that we have for fire and the fear. And then you got somebody that's ready to burn, and then he calls up the dispatch and they say, no, you can't burn. It's not good condition. He's like, no, I need this much wind. No, you can't have to be below this one. It's going to be this. There's just a disaster of all these different little things to try to make it the right situation to get over.
Well, it's not without risk. To burn in Ellsworth County, I pretty much had to give them a DNA sample. They made a legal threat. They said if you let this thing get out of control, I will own everything you own.
There's a lot more days in the summer months and in the fall and spring, you know, late summer, early spring days or early winter days, fall.
It's true.
Than they are in the spring that they'll give you good time.
Shauna, can you take a second and introduce yourself?
Oh, yeah, I'm Shauna Hartman. I'm the fire prevention specialist for Kansas Forest Service. I've worked in this area or in Kansas as a wildfire expert and information officer all around the country for about 20 years.
Well, you have a longer fire season window from August 1st to about September 21st, something like that. More days when weather conditions are acceptable. Green and growing forage, which tends to slow down the fire running through the dead and dormant plant material. You can tolerate a higher degree of wind. There's all kinds of things that make it happy. Yeah.
Going on fire.
So are you recommending an earlier, I know you said the difference between a September and an October burn with not much on the seed stuff there in that one diagram you showed. An earlier summer burn to recreate growth to go into the winter?
The earlier you burn in the summer, the more regrowth you will have. Do you need it? Most people would say, I'd prefer it that way. We added that true fall burn treatment, mostly because everybody was calling it fall burning. And we actually did document some minor negative effects on native vegetation when we took that burning season into mid-October. Indian grass, tillers right up until it goes dormant. And there were years when our fire got really late, okay, that we inhibited that tillering process for the and had fewer Indian grass tillers the subsequent spring. It wasn't long lasting, okay, but it did happen. That's also coincidentally when we saw bluegrass appear more on our plant surveys in those years that followed really late fall fires. That also was temporary. It didn't last.
So you're saying that the ultimate time really to burn is mid-August?
No, I'm saying you got a long window of time. There is no optimum time. You have from October 1st till the first day of, August 1st to the first day of fall, where I think you've got a really good opportunity for control and for improvement.
I feel like your prescriptions for those kind of prescribed burns, they do need more wind, more, less, to push them through a green vegetation. It does need more wind, but there's less restrictions from the counties typically in those time frames when you have green vegetation versus when you're talking about cured vegetation in the spring. Unless you're in a drought. Unless you're in a drought, correct.
The biggest thing is a firefighter is a dispatcher. They're sitting in the dispatch office that think they know. I'm just saying, I don't think half of the dispatchers actually know what the right time to burn is. They just are going off of somebody what they tell them.
And it should be your fire and emergency managers, right?
Yes.
Or county
No.
chief, he makes a decision.
And we do, I'm the chief on one of ours and I've overrode them and they really got torqued. But that's what happened. And they got burned and everything went fine, so.
The dispatchers got upset if you were or who got upset? Who got upset? The dispatchers?
Yeah.
I got shut down a couple times last year. I was like, the weather.
No, the dispatchers were upset that we went ahead and burned because it was an opposite thing to burn. And
Yeah, so I definitely think there's an education piece a lot of times, instead of taking everything into consideration, we focus on wind speed only, and that's when we shut down. There's been times when I've been, good luck to you actually getting a fire started today, because the wind, even if the wind is, plus, 30 miles an hour, you're not gonna hardly get a fire started, but they call a burn ban on, and that's just on wind speed only. And I think that there's some education that we need to definitely put in, that it's holistic, it's not just the wind speed.
very true.
Do you see more smoke production with the summer or fall burn?
It's a good question. Question was, is there more smoke produced? Probably not. What you do get at the point of ignition, you get a lot of water vapor put into the air. That makes the smoke at the point of ignition very thick and intimidating. But when daytime temperatures are warm, normally that smoke cloud is going to ascend to the middle atmosphere, and it will stay there until it hits a cool patch of air, and then it will sink. In the spring, when we get air quality exceedances in Lincoln and in Omaha and in St. Paul and in Knoxville, Tennessee, and even Manhattan Island one time, okay, that's because Flint Hill smoke that was produced in April traveled until it hit a temperature inversion and then it sunk. In the summertime, those temperature inversions are not unheard of, but they're pretty rare. Smoke goes up into the air when it's hot, it stays there, and disperses in the atmosphere before it can descend and create a problem.
Well, Arliss has got our lunch ready. We'll let the last three presenters go first.